Hi, my name is Fabrice Ouaz, and what I want to show you tonight is how to use a WeBalance board to make your LEGO Mindstorm NXT work. Okay, first of all, I'm going to present you the components. I'll be using LEGO Mindstorm's NXT standard box, which contains an intelligent brick, which is equipped with one ARM7 processor. It allows you to connect up to 3 servo motors, 4 sensors. You can also connect it to your laptop using a USB cable or Bluetooth connection. It also has 4 buttons, 1 LCD screen and 1 speaker. The box also contains 3 servo motors, 1 touch sensor, 1 light sensor, 1 ultrasonic sensor, and 1 sound sensor. You can even find more sensors, but those are third parties and they are not bundled within the standard box. You also get one program that enables you to step by step build your robots, and you're also able to program your robots using drag and drop steps, and you connect those steps together, and then as soon as your program is done you can download it to your NXT brick and make the program run on an NXT brick. And now a bit of theory. How do you connect using Bluetooth and Java to the device? First of all, you have to look for a device. Second, you have to look for a service. And then you have to get the connection URL, and then you can connect to the device. How do you discover the device? It's pretty simple. You get a discovery agent using static method, and then you launch an inquiry. As soon as the inquiry returns, it will call back a method that is an interface method you just have to implement, and within the body of the method what you see are not magical numbers. In fact, it's numbers that are defined within the Bluetooth spec to describe any kind of device you can find. And here we've got a toy, which is the major device class, and the minor device class is a robot. As soon as you've got your device, you can find services that are exposed by that device, and then you again use the discovery agent and you launch a service search, and you will be notified by the discovery agent, which will call the callback method, which is called services discovered, which will give you an array of service records. And here we're just looking for one service, because we know that the NXT brick just has one service, and then we're done. As soon as we've got that service record, we just have to get the connection URL from it, and using that connection URL we just use a static method from the connector object to get 2 streams, one output stream and one input stream. Now that you've got your communication channels, you can speak the specific language, because you can't expect every device to speak the same language. So LEGO has defined a specific language which is based on 2 kinds of commands, which are system commands and direct commands. System commands are just to really system, meaning that you can power off the device and that kind of stuff, and we will be focusing on direct commands, which are the useful commands. Here is the commands list. We'll be focusing on set output state, which is used to make a motor spin. So what is message? First of all, you have to specify the message length, because the device doesn't know when it has to stop reading. Then you specify the command type, if it's direct or system commands. And then you specify the name of the comments, and you push the comment body. So here are the comment details. Each command has a specific number. Here for set output state it's 4. Then you've got the output port, which enables you to specify which motor spins, the power, which allows you to make the motor spin in one or the other direction, and it also specifies the speed of the motor. You can specify the mode, turn ratio, the run state if you want the motor to ramp up, run, and then ramp down, and the tackle limit, which specified how much the motor will spin, and if you specify 0, it will spin forever. And then once you have understood that, you can send a command just simply by building a byte array and pushing that byte array on the output stream you got when you connected to the device. It's really that simple, but if you want to make your life easier, you can use iCommand from the Lejos website. It's not maintained anymore, but you can still download it on the website, and using that specific library, you can use one single line of code to send an output state command. It's really that simple. Okay, now what we're going to do is make the Wii balance board and the LEGO Mindstorm NXT robot speak together. And what I want to do is when I walk on the Wii balance board, it will make the LEGO Mindstorm NXT walk. And to do so, as the two devices then speak the same language, the same Bluetooth language, we have to use the laptop to translate the two languages. On the Wii balance board side, here is a piece of code that I'm using to detect that the weight comes from one foot to the other, and as soon as the weight comes from one foot to the other, I send a message to the NXT, which is just making a motor spin that will make the feet of the robot move. Now we're ready to go. What we're going to do is to launch the program. And just have to sync the devices with the laptop. Okay, it's getting launched. Alright, we should be good. Okay, here we go. Let's try to do even more difficult using the iPhone. What we're going to use is the accelerometers of the iPhone, and whenever the iPhone moves, we're going to send a message to a JMS queue and forward that message to the robots. To do so, we're going to use ActiveMQ, which is an open source implementation of JMS, which has the ability to receive a message using a REST code. So what the iPhone is going to do is to simply send a GET request to an HTTP URL, and this will transform to a JMS message. This message will be listened to by our Java codes, will then in turn send a message to the robots to make the motor moves so that the robot moves. Okay, this is the overview of all will happen. This is what it will look like on the iPhone. Here we can see the Lego Walk icon. This is the launch screen, and this is the interface, which is really pretty simple. Okay, let's go again. We're launching message queue, and just launching the program again. Just have to